Good day, everyone. In this video, I'm going to show you how to draw a front elevation from a given sketch plan. And the first thing you need to do is to study the specifications given to you. When you look at the specification, we have the foundation, the floor, the steps, the walls, the doors, the windows, the lintel, the beam, and the roof with their dimensions. So let's see the sketch plan in order for us to know what to do. So this is the sketch plan. How do you identify your front elevation? Your front elevation is the part where you can assess the building. As you can see, from here you have the steps, and you have the veranda. So from this part of the building, you can easily assess the building. So towards your left hand, it is called the left end view, and towards your right hand, it is called the right end view. Then the back, which is the last side, is called the rear view. So let's quickly see how to draw the front elevation from the sketch plan. So now when you look at this drawing, there is a ridge at the middle. There's a ridge at the middle, so this is the ridge line. So the ridge line is positioned horizontally. What does it mean? It means that the slope of the building will come towards the side and towards the other side. That means when you're looking at the front elevation, the shape of your roof will look like a rectangle because the ridge is positioned horizontally. Now I want to start drawing. The first thing you're going to do, you bring out your ruler and draw a thin line. The thin line you're going to draw will represent the natural ground level. Represents the natural ground level. When you are done with the natural ground level, you quickly bring out the length of the building. How do you get the length of the building? It will be given to you, or you add the summation of 5,000 to 5,000 plus 5,000 plus 4,000. That gives you 14,000. So you measure 14,000 at any point on the line. Measure 14,000 and draw a perpendicular line. So from this point, I'll call this point my point A. So this point, which is point B, is my 14,000, which is the length of the building. The length of the building is 14,000. 5,000 plus 5,000 plus 4. So now, how do I get the height of the building? The height of the building will be given in the specification. So when you study the specification, you will see that the height of floor to ceiling is 3,100. Height of floor to ceiling is 3,100. So you go back to your line and you measure from the floor to the ceiling, which is what, 3,100. But before you will get that part, you will first bring out the distance from the height, from the floor level to the ground level. From the floor level to the ground level, you have it in the specification as this. Floor level is 450 higher than ground level. So you go back, this is called the natural ground level. So make sure you put it faintly, that is the NGL, the natural ground level. So this is your natural ground level, and there is in the specification you have a distance of 450 mm between the natural ground level and the floor level. So you measure 450, place your ruler at this point, measure 450 up, and bring out your floor level, because the specification says your floor level is 450 mm higher than the natural ground level. Now, when you want to bring out the floor level, you make use of your thin short dashes to bring out the floor level. Thin short dashes. After you have done this, you now bring out the height of the building. I'll go back to the specification to show you the height of the building. which is which is height of floor to ceiling 3001. Height of floor to ceiling, what does it mean? It means that the height from the floor level to ceiling is what? 3100. So place your ruler at this point and measure 3100 to this point. Now once you get that height, put a thin line at the top to indicate the height of the floor level to the ceiling, 3100. So my 3100 starts from the floor level to the ceiling, the soffit of the ceiling. So that is my 3100. So after you have drawn that, the next thing to do, indicate your floor level with FL. Indicate your floor level with FL and put it by the side of the thin short dashes. Then the next thing to do is to draw the eaves projection. When you study the specification on roof, you will see that you have 900 eaves projection. Eave is an extension from the external wall of the building outside. Projection from the external wall outward. So now this is the external wall and this is another external wall. So we are going to measure 900 from this point outward to the left, and you do the same thing 900 outward to the right. So you bring out your ruler and you measure 0.9, measure 0.9 to your left, and measure 0.9 to your right. That gives the eave projection. It gives the eave projection. When you are done with the eave projection, the next thing to do is to bring out the facial board. What is the essence of using the facial board? The use of facial board is to conceal the roof truss, the side of the roof truss that projects outward. So there is need to use the facial board to close it up. So how do you draw the facial board? Using the given specification. If it is given from the specification, you use it. If it's not given, you measure 0.225 or 0.23, preferably 0.225. Bring it out. It is in form of a rectangle. So this is the facial board. After you are done with the facial board, the next thing to bring out is the roof covering. And the roof covering will project a little bit outward from the facial board. The reason is just for to avoid the penetration of water, or to avoid rain, the penetration of rain directly on the wood. So you bring out the roof covering, and the projection is no more than 0.1 or 0.2, at most 0.2. Then once you bring it out, you complete your rectangle. Don't forget, the reason why we are drawing rectangle is because the ridge is positioned horizontally. So you have it as a rectangle. So when you are done with this, and I'll give you the height of the roofing sheet. The height of the roofing sheet is no more than 1.2, between 1.2 and 1.5. Let me put it beside this. The height is between 1.2 to 1.5. It takes the height of the king post. So it's between 1.2 and 1.5. Then the height of your building that is given to you is 3.1. Height from the natural ground level to the floor level is 0.45. So when you are drawing, you are not to place the dimensions by the side of the building. You are not to place the dimension. The only thing that should appear on the elevation is the NGL, the FL, and the title of your drawing, which is front elevation. Front elevation, scale 1 to 100. That is the only thing that should appear on the drawing. So this is the title, front elevation, scale 1 to 100, well lettered. So now let's go back to the sketch plan and see what we are here to draw from the given sketch plan. So now when you look at the veranda, you will see steps. This is 1 and this is 2. So we are going to fix the steps. How do we fix the steps? Go back to the drawing, check the dimension between this part, which is 4,000 from the external wall towards your towards your right end, you have 4,000. When you measure 4,000, the step starts immediately after the 4,000 to the middle of the plan, to the middle of the dimension of the veranda, almost the middle. So you position it that way. Just follow whatever dimension is given to you. Position your ruler and measure 4,000. After 4,000, I can fix my step. After 4,000, I can fix my step. When it appears in the elevation, it appears as rectangle. The step appears as rectangle, 2 rectangles. So all you need to do is just fix 2 equal rectangles because they have the same riser. So fix 2 equal rectangles. Once you are done with that, go back to the sketch plan, check what is remaining. We are yet to fix this window, W1. W1 is the window for the kitchen. So we go to the specification and see what is the dimension of W1. W1, the size of W1 is 900 by 600. 900 by 600 top on casement window. It's a casement window. So we go back and fix the window. Then when you want to fix your window, try and study the position of the window. The window is fixed in between 4,000. From here to here is 4,000. So you fix the window in between 4,000. So I'll go back and I'll measure from here to here. I've already measured out 4,000. So in between here, I'll fix my window. Now, for you to fix your window and to fix it properly, you need to take the height of the door. The height of the door is given to you as 2.1. So what do I mean? I'll measure out the height of the door, which is 2.1, for me to bring out any window soever. Any window given, the first thing I'll bring out is the dimension, is the height of the door from the floor level. And the height of the door is 2.1. That is the height of a standard door, 2.1. So I will mark out 2.1. Once I finish marking out 2.1, I'll bring my ruler. I'll draw a faint line on the marked point, which is 2.1, a very faint line. I can take it all the way if there's need for me to draw other things. Now, from here to my floor level, it is 2.1. What I need to fix is my window, but the first thing I will do is to bring out the height of the door, which is 2.1. Why do I need to bring out the height of the door before I fix my window? Because they must follow the same pattern. They must go on the same level. The height must be the same. So when I check my W1, I have 900 by 600. 900 is the width, while 600 is the height of my window. So I will now go to the marked points, bring out in between 4,000, in between the external wall and 4,000, and to fix my window around here. Then it will start from 2.1. From 2.1, I'll position it in between this way, and I'll bring down this height, which is 600. That's the height of my window. 600 height by width of 900. Assume this is my 900 width. Then I'll close it up. I'll close it up. So I've been able to carve out my window W1, 600 by 900, 600 height by 900 width. Then because it's a casement window, I'll draw out the casement. I'll bring out my frame. Now this is my window. Then to show that it's made of glass, I'll fix in this at the middle. After I've successfully drawn my window, I will go back and see the next thing to bring out, which is door. Because when you are here, when you are positioned at the front view, you will see W1. When you climb through the steps, you also see your double door and your window too. So now how do I position my double door? Because I've already fixed my window. The next thing is to fix the double door. How do I position the double door? The double door will be positioned immediately after this partition wall. After this partition wall, you have just a tiny wall, then you have the double door. So after my measurement of 4,000, which is this, I'll just leave a tiny space for the wall. Then I'll fix my double door. The measurement for the double door, let's say the size of the double door DD is 2001 by 1800. 2001 is the height, 1800 is the width, and 38 is the thickness of the door. So I've already projected my 2001, which is the height of the door. Then I'll measure my width from this height. I can easily get my width of 1800. I'll bring out 1800, which is the width of the door. Then because it's a double door, I will divide it into two. I will divide it into two. Then when you look at the specification, you'll be able to know the type of door. You'll be able to know the type of door you're drawing. From the specification, it says panel, all doors glaze 3 panel, 225 by 50 timber frame, glazed 3 panel in 225 by 50 timber frame. So it's a panel door. It's a panel door. So we have the timber frame. All you need to do is just to fix in the glaze. Glaze means glass. You fix the glass. Because the number of panel was not given. If it's 2 panel, you draw just 2 boxes to show the panel. So I have 2 boxes. So to show that it is glazed, you can just indicate it with glass. You can make the upper part glass and the lower part can just be made of wood with the same 2 boxes. You can as well fix the door handle. Now, once you're done with the doors, with the double door, you go back to the sketch plan and see the nesting. So we've been able to fix the double door, remaining the window, which is W2. So go back to the specification and look for W2. We have W1, W2 is not given, so we are going to assume a dimension of 1002 by 1002. So we look at the position of the W2. W2 is also positioned after 5,000 length of the WC and bat. After 5,000, you position W2. Bring out your ruler and measure 5,000 from the external wall. Anywhere it stops, you bring out your W2. You also start from the height, which is 2.1, and bring it to a height of 1.2. You start from this height that we have drawn before, which is 2.1 from the floor level. Then you bring out from that height, you carve out the height of the window, which is 1002. So this height is 1002 by a width of 1002. I assume this is 1002 by a width of 1002. You divide it into two in order to show the frames. So bring out the frames at the edges. From the specification, we have it as casement window. Remember to fix the symbol, to use the symbol of glass. So once you are done with this, you're good to go. The next thing is just to remove this part of the line because it must not be seen. So after you have drawn this, after you have drawn this, you need to bring out the ridge cap. The ridge cap is just a tiny rectangle from the roofing sheet. So you can measure 0.1 to be able to bring out the ridge cap. So this is the end.